In this video, we're going to learn our other two shortcuts to show that two triangles are congruent. Last time we saw SSS and SAS. Those were side, 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 and side angle, side. For today, we've got angle, side angle, and angle, angle, side. So on the left here, I know that these triangles are named the same, but you can kind of tell you've got those red sides highlighted where the two congruent angle pairs, like angle B and angle A, angle E and angle D, they connect the congruent side AB and the congruent side DE. So this would be an example of angle, side, angle, those two triangles there on the left. On the right, if you take a look at the congruence parts, you've got an angle with those double arcs at A and D, an angle with the single arcs at B and E, and then a side following that, BC and EF. So this would be an example of angle, angle, side. So when you're trying to figure out which shortcut are we using, SSS, SAS, ASA, or AAS, we're going to abbreviate those following ways. You want to take a look at which things are congruent and which order they show up in their congruence. So let's take a look at an example here. In the upper left corner, we've got those two triangles. Notice we don't have any angle congruence. So that kind of throws off angle, side, angle, 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 side, and side, angle, side. The only option left would be side, side, side. And that would apply to those two triangles in the upper left corner because all sides are congruent to all other sides. If we take a look at the bottom two triangles, I've got a bunch of angles congruent, but I don't have any sides. All of those shortcuts, SSS, SAS, ASA, and AAS, all have at least one S, meaning you have to have at least one side pair congruent. Here I don't have any. So here, no shortcut would be used to show that those are congruent. In fact, they may not even be congruent. For the two triangles in the upper right corner, you've got an angle pair with single arcs, followed by a side pair with one tick mark, followed by another side pair with two tick marks. This would be, if it was a shortcut, angle, side, side, and that's not a good shortcut to use. If you abbreviate that, it might not spell a good word. Probably a good hint that it doesn't actually work. And so angle, side, side is not a useful tool. It does not help us show congruence. There are actually many counter examples. So those bottom two right triangles, I should say just bottom two triangles, and those upper right-hand corner two triangles, those are not congruent triangle pairs because none of the shortcuts apply. But if we take a look at these pairs, triangle BAD and CAT on the left there, they have those congruent marks on BD and CT. And then you have some parallel arrows. So you could, using parallel lines in their angle relationships, conclude that angle D is congruent to angle C. You could also conclude that angle B is congruent to angle T. So this could be a case of angle, side angle. If you wanted to, you could also look at the angles with vertex A, BAD and CAT. Those two angles, along with another angle pair, could give you angle, angle, side. And in fact, anytime you use angle, side, angle, you could also use angle, angle, side. The goal is to use whichever one is easiest or quickest applies in every situation. On the right side there, we've got an equilateral triangle, TRY, and N is the midpoint. So if you make some congruent marks, TR is congruent to RY because all of the sides of equilateral triangles are congruent. If N is a midpoint, that means TN is congruent to NY, and they share that side RN. So this is a case of side, side, side. Now, all of these triangle pairs are going to be jumbled up together. They're not always going to be grouped in terms of side, 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 side angle, side, etc. In this section, we have all four options on the table now. Looking at this last set of triangles, on the left, I have A as the midpoint of DC and BT. So if you were to mark up some congruent segments, you could say BA congruent to AT, DA congruent to AC. And then if you look at your parallel arrows, you could also conclude that angle B congruent to angle T, angle D congruent to angle C. You also have vertical angles. So actually, that pair of triangles could be side, angle, side. It could also be angle, angle, side. And it could be angle, side, angle, depending on what congruence you want to use. The last pair here on the right, we've got some congruent marks. And if you go in order, you have single arcs to double arcs, and then they share that side kind of in the middle here, where those two double arc angles are congruent. So this one would easiest be, if that's a word, I should say the easiest way to identify this one would be angle, side, because you could put some tick marks, or at least one tick mark, on that side that they have in common. So for this section, just be ready to identify the 4 different shortcuts, now that we have 4 of them, SSS, SAS, ASA, and AAS, in any given situation. And remember, these are the 4 shortcuts we're going to use to prove triangles congruent. It'll cut down a lot of that work. That should do it for 4.5.